Empirical formula. How we can find empirical formula? So first definition of empirical formula. An empirical formula a formula which represents the simplest ratio of the atoms of each element present in a compound. That formula is known as empirical formula. Sometime percentage is given, sometime mass is given, or sometime percentage by mass is given. So what is this step one? Divide each either a mass or a percentage by atomic mass of the element. That's the first step. What is step two? For each of the answers from step one, divide by the smallest one of those to take a simplest ratio. Then sometime the number in number calculated in step two need to be multiplied to give a whole number. Those whole number will be empirical formula. For example, calculate empirical formula of a compound that contain 1.82 grams of potassium, 5.93 grams of iodine, and 2.24 grams of oxygen. So there is potassium, there is iodine, and oxygen is present in a compound. They mention 1.82 grams of potassium, 5.93 grams of iodine, and 2.24 grams of oxygen. So if we need, first step is divide by atomic mass. So atomic mass of potassium is 39.91. Atomic mass of iodine is 126.9. And atomic mass of oxygen is 16. So you will divide by 16. Then when you divide 1.82 divided by 39.1, that will give you 0.0465. Same thing, 5.93 divided by 126.9, not 7, this was 9. So you will get 0.0467. And 2.24 divided by 16, you will get 0.14. Then divide by, you want to take a simplest ratio, so you will divide by smallest value in the combination. So smallest value in the combination is 0.046. When you divide and convert them into whole number, that will be 1, 1, and 3. So what is the empirical formula of this compound? It is KiO3, so potassium iodate, 5 is there. Is it clear how to find empirical formula of a compound? Any doubt in this? Molecular formula of a compound. How you can find molecular formula? So from empirical formula you can find the molecular formula which represent the actual number of atoms of each element present in a compound. So empirical formula times n is equals to molecular formula, and where n is equals to molecular mass divided by empirical mass. So molecular mass divided by empirical mass, you will get the value of n, and using this n, you can find the molecular formula. So the question example is, work out the molecular formula of a compound with the empirical formula C3H6O and molecular mass is 116. So first you need a value of n. Value of n is equals to molecular mass, which is 116, divided by empirical mass. How to find empirical mass of carbon is 12 multiplied by 3 plus hydrogen is 1 multiplied by 6 plus oxygen is 16. 12 multiplied by 3 is 36, plus 6 is 42, plus 16 is 58. So empirical mass is equal to 58. So value of n, because 116 divided by 58, that will give you 2. So value of n is equals to 2. So molecular formula multiplied by empirical formula multiplied by n will give you the molecular formula. So empirical formula was C3H6O multiplied by n. What is n? N is equals to 2. So this 2 is multiplied with carbon, this 2 is multiplied with hydrogen, and this 2 is multiplied with now in the question there is one. Why we are not multiply? Because it contains 3 carbon, it contains 6 hydrogen, and it contains 1 oxygen. That's why it's only 16. And this 2 is also multiplied. So 3 multiplied by 2, 6. 6 carbon, 6 multiplied by 2, 12 hydrogen, and 2 multiplied by 1, 2 oxygen. So that is molecular formula. Is it clear? So using empirical formula times n will give you the molecular formula. Is it clear? Yes. Then converting the quantities between the different substances using a balance equation. So what we can do, for equation we can take moles to moles ratio. Moles to moles ratio. We can take mass ratio. Or we can take moles to volume ratio. Volume of a gas, moles of a gas and volume of a gas. But there is no ratio, there is no ratio between the mass and the mole. You cannot take that ratio, or moles and mass. Only these 3 ratios can be taken to solve a question related to moles, mass, or volume. So example, what mass of carbon dioxide would produce from heating 5.5 grams of sodium hydrogen carbonate? And the equation is given. So mass of sodium hydrogen carbonate is given, and you need mass of carbon dioxide. So if mass is given, take the mass ratio. Or first you can convert into moles and take a mole ratio, and then again convert into mass. But here it's better because we can just take a mass to mass ratio if mass is given and mass is required. So we can take the mass to mass ratio. How we can take a mass to mass ratio? So that what is the total mass of sodium hydrogen carbonate? It is 2 NaHCO3, and carbon dioxide is CO2. So if I take a mass to mass ratio, so sodium is 23, it will be times 2, because this 2 is multiplied with all the elements. Plus hydrogen is 1 multiplied by 2, plus carbon is 12 multiplied by 2, plus oxygen 16 multiplied by 6. So 23 multiplied by 2, so it will be 46 plus 248 plus 1260 plus 96. So sodium hydrogen carbonate, sodium 23 multiplied by 2, or you can first take the mass of the sodium carbonate, hydrogen carbonate, and multiply it by 2. So sodium is 23 plus hydrogen is 1 plus carbon is 12 plus oxygen is 16 multiplied by 3. So this will be 23 plus 1, 24. 23 plus 1, 24 plus 12, 36, 36 plus 48. So it will be 84. 84 multiplied by 2. So that will be equal to 168. So you will have 168 here. This total mass is 168. So that was just a solution. So I can write 168 with sodium hydrogen carbonate, the total mass. Carbon dioxide, carbon is 12, oxygen 16 multiplied by 2. 32 plus 12 makes it 44. So simplest ratio of the mass is 168 is to 44. But in the question we have only 5.5 grams. So if we have 5.5 grams, then this will be X cross multiply. So X is equals to 5.5 multiplied by 44 divided by 168. So X will be equal to 1.44 grams. That's the final answer. Is it clear? So mass was given and mass is required, so that's why I took the mass ratio. Is it clear? Any doubt in this example? Next, what mass of copper would react completely with 150 cm cube of 1.6 mole per dm cube nitric acid? So first thing, because either I can take a mole ratio or I can take mass ratio. So neither moles nor mass is given. So they did not give the moles, they did not give the mass. So what we will do, we will first find the moles of this acid, nitric acid. So moles of nitric acid is concentration multiplied by volume. Concentration is 1.6 and the volume is 150 cm cube, but it should be in dm cube, so it will be 150 divided by 1000. So we'll get the moles, how many moles of nitric acid? So 1.6 divided by 0.05, 0.15, that will give you 0.24 moles. So we have 0.24 moles of nitric acid. But the question is, find the mass of copper. So from moles of nitric acid, 0.24 moles of nitric acid, they will find the mass, moles of copper. So what is the simplest ratio of the moles for nitric acid and copper? 8:3. So if it's 0.24, then this will be X. Cross multiply. So X is equals to 0.24 multiplied by 3 divided by 8. So X is equals to, when you calculate the moles, 0.24 multiplied by 3 divided by 8, you will get the moles of, which is 0.09. And after getting the moles, but the main question is find the mass. So moles multiplied by molar mass of 0.09 multiplied by molar mass of, or atomic mass of copper 63.5, will get 5.71 grams. Is it clear? Any doubt in this? Okay, next question is, what volume in cm cube of oxygen gas would produce from decomposition of 0.532 grams of potassium chlorate? This I want you to solve and mention the answer in a chat. Potassium 39, chlorine 35.5, oxygen 16. Yeah, what could be the answer? Mention, solve this and mention answer in a chat. Okay, let's check the answer. It's 156 cm cube. The question is volume. So first, you work out you have 0.53 grams of potassium chlorate, you got the moles. Using a mole ratio of potassium chlorate, you got the moles of oxygen. And from moles of oxygen multiply by 24, you will get the volume. Because the question was find the volume of oxygen, not the mass of oxygen. Is it clear? Then you can also use the ratio of the volume, ratio of the moles to find the volume. But keep in mind that the condition to use the ratios here, that it should be standard condition like temperature 298 Kelvin or 25 degrees centigrade, or atmospheric pressure should be 1 atm or 100,000 Pascal. So if a question is, if one burned 500 cm cube of methane, what volume of oxygen would be needed and what volume of carbon dioxide would be given off? So how you can use the ratio between methane and oxygen according to the question. It's 1:2. So 1:2 is the simplest ratio. If we have 500 cm cube of methane, then we'll have x cm cube of oxygen, cross multiply. So what we will get? We will get oxygen should be twice. So oxygen should be 1000 centimeter cube. When we are taking a ratio, we don't have to convert the unit. Later we can convert, but in a ratio, we'll get the answer same way. How much carbon dioxide is there? So simplest ratio between methane and carbon dioxide is 1:1. So 500 cm cube will be x, cross multiply. So x is equals to 500 cm. So we'll get the same amount of carbon dioxide. Is it clear, this example? Any doubt in this? An important reaction which occur at a catalytic converter. In this reaction, 500 cm cube of carbon monoxide and 500 cm cube of oxide of nitrogen at 1 atm. Calculate the total volume of a gases produced at same temperature and pressure. What will be the answer? Example 13. What could be the answer for this? For it's 750. Why it is 750? Whenever both reactants are given, first thing you have to know the limiting reagent. So carbon monoxide and oxide of nitrogen, the simplest ratio is 2:2. Or I can say simplest ratio 1:1 or 2:2. So if I have 500 cm cube of carbon monoxide, how much oxide of nitrogen I need? X. Cross multiply. So we need the same amount of oxide of nitrogen. So there is no limiting reagent. If there is no limiting reagent, it means both of the reactant used up. But what about the product? You can use any of the reactant to get the product, because in this example, there is no limiting reagent. So carbon monoxide to carbon dioxide, what is the simplest ratio? So carbon monoxide to carbon dioxide simplest ratio is 2:2. So if we have 500 cm cube of carbon monoxide, how much carbon dioxide will be there? X. Cross multiply. So you will get 500 cm cube of carbon dioxide. And from carbon monoxide, you will find nitrogen. So from carbon monoxide to nitrogen, what is the simplest ratio of the mole? 2:1. Mole ratio and volume ratio will be same. So if we have 500 cm cube, then this will be X. Cross multiply. So value of X is equals to 250, half of carbon monoxide. So 250 cm cube of nitrogen is there and 500 cm cube of carbon dioxide is there. What is the total volume of a gas produced? 500 plus 250, that will give 750 centimeter cube. Is it clear? When equation is given, you have to use the ratio. Is it clear? Next is the percentage yield. The percentage yield, practically when we carry out the experiment, we always get a smaller amount as compared to what a theory suggests. So the percentage yield is the practical value of a product divided by theoretical value multiplied by 100. So example, in this example 14, 25 grams of iron 3 oxide reacted and produced 10 gram of iron. So this is a practical value. Practically we are getting 10 grams of iron. What is the percentage yield? So we need a theoretical value because practically we are getting 10. So how to know the theoretical value? We have the equation. So we'll take a ratio of the, if mass is given, we'll take a ratio of mass of iron oxide with carbon with iron, because so iron oxide to iron. So iron is 56 multiplied by 2, 112 plus 3 multiplied by 16, 48. So that will be 160. So this is 160. Iron is 56 multiplied by 2, so 112. So 160 gram, if we have 160 gram of iron oxide, theoretical value means the mass according to the simplest ratio or amount according to the simplest ratio from the equation, that's called a theoretical value. Actually, actual value when you do or carry out experiment, it's always lower. So 160 gram, if 160 gram of iron oxide is there, it will give 112. But if we have 25 grams of iron oxide, how much iron should be there? X. Cross multiply. So when you cross multiply, how much iron you should get? You should get 17.48 grams of iron. So theory, according to equation, it suggests you should get 17.48 grams of iron. But practically, you're not getting 17, you're only getting 10. So percentage yield is a practical value, which is 10, divided by theoretical value, which is 17.48, multiplied by 100. So when you calculate percentage yield, it will be 57.2. So practically, you will always get a smaller quantity as compared to what theory suggests, what is suggested according to equation. So ratio, the simplest ratio from equation will always suggest that you should get more product. But practically, when you do the experiment, you will get the less product. And the comparison between the practical value divided by theoretical value into 100 will give you percentage yield. And what is the reason why the percentage yield will be lower? These are the reasons. Percentage yield can be lowered through incomplete reaction. Maybe reaction is incomplete or reaction is not completed. Maybe side reaction. What does it mean, side reaction? Maybe a substance which is produced here, like iron produced here, iron may react with another substance, and that we call a side reaction. Maybe some of the mass is lost during a reaction, lost during a transfer, lost during purification stages. So if the question is why the percentage yield is less or lower, these are the few reasons why the percentage yield for any reaction is lower. So practically, you will always get a small quantity or a small amount of a product as compared to what a theory suggests. Is it clear? Then what is percentage atom economy? It's a mass of a desired product or a useful product divided by total mass of reactant multiplied by 100, or it is mass of useful product divided by total mass of all reactant, mass of product multiplied by 100, you will get atom economy or percentage atom economy. So example, the question is, what is the percent atom economy for the following reaction where iron is the desired product or iron is a useful product? So what is the formula? Mass of useful product. So what is a useful product for us? Iron is a useful product. So what is the total mass? And it is always calculated from equation. We don't need any other thing. We just need equation to calculate the percentage atom economy. So mass of a desired product. So what is the mass of a desired product? Iron is the desired product. We want iron. So it will be 2 multiplied by 56 divided by total mass of a reactant or total mass of a product. So I can find the total mass of reactant or I can find the total mass of product. So total mass of reactant, it will be 56 multiplied by 2 plus oxygen is 16 multiplied by 3 plus carbon monoxide. So carbon is 3 multiplied by, or carbon monoxide is, carbon is 12 plus oxygen is 16. So 12 plus 16, that will be equal to 28. When we solve this, and then it is multiplied by 100. So percentage atom economy is equals to 45.8%. So we just need equation to calculate the percentage atom economy. What is the advantage of using this term? So this shows the sustainability of reaction. So sustainable chemistry requires a chemist to design a process which is having higher atom economy that minimize the waste product. Like, for example, if you have any reaction which is having higher atom economy for desired product, so you prefer that. Why you prefer that? Because it shows that it will have less uh, waste product, so increase the amount of the useful product and reduce the cost. So if I give an example, like if I say calculate the atom economy so if you have a reaction CH4 reacted with chlorine, substitution reaction occur, chlorine will take position of hydrogen and hydrogen. So the formula, if I say what is the atom economy for desired product is what we want to produce, chloromethane CH3Cl. So if you want to produce a chloromethane is our desired product. So the percentage atom economy is a mass of a desired product. So what is the mass of desired product? This is our desired product. So carbon is 12 plus hydrogen is 3, because 1 multiplied by 3, that's 3, and chlorine is 35.5 divided by total mass of reactant or total mass of product. So how to find total mass? So carbon is 12 plus hydrogen is 4, so that's 16, and chlorine is 35.5 multiplied by 2. So 12 multiplied by 12 plus 3, 15, and 15 plus 35.5, so it is 50.5. Divided by, so 35.5 multiplied by 2, that's equal to 71. 71 plus 16, that is equals to 87. And its formula multiplied by 100. So if you multiply it by 100, so what we have, the final answer as 50.5 is divided by 87. So it is, and multiplied by 100, so our final answer is 58%. Is it clear? The concept of atom economy of a chemical reaction. Any doubt in this? Okay, some questions we'll discuss related to this atom economy. I'll share a file with you. Just a minute.